All right, so I'm going to give you a brief description of how to name alkynes. So alkyne, it refers to a carbon containing compound that contains at least one triple bond between the carbons. So whenever you have a triple bond, we're going to be making sure that we know that the carbon there is still going to only need 4 bonds to it. So when there's 3, if your triple bond is on the end, you would only need one hydrogen over here to make it a total of 4. So then as we go off this way, you're only going to need 1 going off this way. So let's start out with a simple alkyne. We're going to go back to our original rules that we learned about naming alkanes and generally just naming our hydrocarbons. And that's going to be to find your longest chain. That's going to be 1, 2, 3, 4. So we have 4, and 4 is interpreted into bute. And now we're going to be giving it the YNE ending because we have a triple bond present. So the name of this will be butene. Now, whenever you have more than a single bond, so you either have if you have an alkene or an alkyne, you have to put a number for where that bond, that triple bond starts. And you're going to always give that the lowest number possible. So in this case, this would be the number 1 carbon. And so that's where we would know that we would need to draw the triple bond is at the 1 carbon. So we're going to put a 1 here and then a hyphen and then butene. That tells us 1 is where the location is. And then bute tells us that there's 4 total carbons. And then ine tells us that what's at that 1 is a triple bond. If this was 1 butene, then it would be just a double bond right there instead of a triple bond. So now what if we have substituents on an alkyne? So in that case, well, really there was only, I guess there was 2 steps here. You had to number the location of the triple bond. All right. What if we have a substituent or a branch? So if we have a, a compound like this, where we have a triple bond, and then we have a chain, and then we see that we have a substituent or a branch over here. We're going to always go back to our first step, which is circle your longest chain. And in this case, the rules are that your longest chain has to contain both of the carbons that are in that triple bond. So that means that we're going to go ahead and circle this guy as our long chain. So we can count the carbons there. 1, 2, 3, 4, 5, 6 carbons. And that is interpreted as a hex. Because we have the triple bond, we give it the YNE ending. But we notice that this isn't just hexyne, right? Well, we have to number it too. If we're going to number it, we need to number it based on where the triple bond is. And that, again, is going to be at the 1. So that's the 1, 2, 3, 4, 5, and 6 carbon. So we will give it a 1 hexyne tells us where the triple bond is and that there's 6 carbons. But notice, oh, we've got this substituent up here. And so just going back to our substituent rules, we know that we need to give a location and a name for the substituent. And we're going to put it in front of 1-hexyne. So for this one, we've got a methyl group at the 5 that's coming off of the 5 carbon of the chain. And so we're going to call this then 5-methyl one hexyne. All right.